Now what we want to do is have a look at equations that are going to be in this form. And it's going to be a number times sine x plus a number times cos x. And it might be equal to 0. It might be equal to any number. It could just be any number there. It doesn't really have to equal 0. What this leaves us with a problem, because sine x or cos x, we can't just manipulate these ones to suit what we need. So if it's equal to 0, it's not a bad manipulation. We can manipulate it. If it's any other number, we can't. So what we want to do is write something like a sine x b cos x in this form, where you've got some number times sine of x plus an angle. So where from that we could say that r cos theta alpha here, when we expand it out, so we're looking at this, if we're looking at this manipulation and say in this case we get r cos alpha would be equal to a, and b would be equal to r sine theta, because we've got the relationship here, and then we can start to manipulate these. So we've got that situation. What we want to do is find what these values of r would be and what the relationship is. So a sine x b cos x is equal to these ones. So they're just manipulating these equations here, because these two are equal, so we can have that situation. So we're manipulating those, cancelling the sine x cos x. Well, don't even have to do that, because what's in front of them, because they're the same, what's in front of them must be equal. So a is equal to r cos alpha, b is equal to r sine alpha. Now, if I square them, I want to solve them to get r there. If we square them and add them together, so a squared plus b squared, and r squared cos squared alpha plus r squared sine squared alpha, factorise your r squared out. That part would be 1, because r cos squared alpha plus sine squared alpha is equal to a squared plus b squared. So r squared is equal to a squared plus b squared, or r is equal to a squared plus b squared. So there's your value of r. So from this manipulation here, if we want to put that into that value, into that situation there, r here would be equal to square root of a squared plus b squared. And then we have to find this angle alpha, which is not too hard, because again we go back to what we had before and put cos alpha as a on r, sine alpha as b on r, and then just divide sine on cos. B on r gives on a on r gives us b on a, so that means that's tan alpha, and then we take in tan of alpha would equal b on a, so alpha is equal to the inverse of tan of b on a. So there's how we're going to get those values, and we can write all those in, no matter what type of equation we get, we can write any of those in these formats. Each case, r is equal to square root of a squared plus b squared, and tan alpha is equal to b on a, whatever the b value is there. So that's how we're going to be doing that in the next few questions.